Good morning, everyone. Good morning, Vinita ma'am.
Morning, ma'am.
Good morning, ma'am.
Good morning, Vinita ma'am. Ma'am, can we
Yeah.
start?
Yes. Good morning, Dr. Sarkar. I've been waiting. Yeah.
Yeah, ma'am. Ma'am, we'll start.
Yeah.
Aditi, please start.
Yeah, ma'am. A very good morning to respected guest speaker, Dr. Vinta Gupta. Hello, ma'am. Am I audible?
Yes,
Hello,
you are
ma'am.
audible.
Yes, you are.
Yeah, you are audible.
A very good morning to respected guest speaker, Dr. Vinita Gupta, ma'am. Honorable management members, respected principal, ma'am, teachers, and all the participants. On behalf of the Department of Chemistry of J.V.M's Degree College, I, Aditi Chaurasia
Good
from
morning, ma'am.
welcome you all to today's webinar on career prospects in chemistry. Before heading on with the webinar, let's bring light upon the reason why we all have gathered here today. Career prospects in chemistry. Deciding the perfect career for ourselves is a very difficult decision in today's world. We can find opportunities in all the field, but choosing the field in which we can invest a lifetime is a big confusion. So we have here today our guest speaker, Dr. Vinita Gupta ma'am, to guide all of us and make our path to success easy and clear. The objective of our today's webinars are to learn the role of chemistry in social development, to understand the various career options in chemistry, and let's know about the fellowship and opportunities of research in India. Now, I would like to call upon Dr. Shweta Rathore ma'am to introduce our today's speaker, Dr. Mrs. Vinita Gupta.
Thank you, Aditi. A very good morning to all of you. I, Dr. Shweta Rathore, feel honored to welcome our guest speaker, Dr. Vinita Grover Gupta ma'am. She has joined Bhabha Atomic Research Center in 2001 after her post graduation in chemistry from Indian Institute of Technology, Delhi, where she was the topper of her batch. She did her PhD from Mumbai University. Her research interests lie in material for nuclear and electrical applications. In context of nuclear materials, she worked extensively on structural, thermophysical properties and radiation response of potential material for futuristic reactor technologies. Her research work also involves structure property relationship in complex oxides for electrical, optical, and photocatalytic applications. She has to earn credit more than 90 publications, in addition to several book chapters. She is the recipient of several awards, notable among which are Young Scientist Award from Department of Atomic Energy, Indian Nuclear Society, and Indian Society of Chemists and Biologists. DAE Scientific Excellence Award, IANSCAS Dr. Tarun Datta Memorial Award. She is the winner of IUPAC Young Chemist Program 2007. She is a fellow Maharashtra Academy of Sciences and Associate Academician, Asia Pacific Academy of Material. So welcome you, ma'am. Thank you so much. Over to you, ma'am.
Can I now start, Dr. Sarkar?
Yes, ma'am. Yes, ma'am.
Okay. Okay, is my screen visible?
Yes, ma'am.
Okay. So a very, very warm good morning to all of you. Thank you, Aditi, and thank you, Dr. Rathore, for this very kind words. It's a pleasure being here today morning with the students. I don't think any morning can start better than being with students, and I really envy you teachers for that. So thank you very much. So basically, today's event is one of the series of Azadi Ka Amrit Mahotsav that is being celebrated by Government of India. So all of you know that Government of India has initiated this festival. It is a Mahotsav that is called Azadi Ka Amrit Mahotsav. It was initiated, it commenced on 12th March 12th March 2000, this thing, last year of 12th March 21, and it will go on till 15th August 23. So all the ministries of Government of India basically are contributing to celebrating this festival by organizing various demonstrations, exhibitions, outreach program. And today's event is one such step in that direction, in which we would like to connect to our younger citizens. And basically, out of several topics, this was one topic I chose because I thought this would probably of a lot of concern to you people regarding this. Okay, so let us start this. I hope everything is okay in terms of voice and the screen sharing, screen viewing.
Yes, ma'am.
Yeah, ma'am.
Okay. So I shall start. Okay. Now I was told that we also have 11th and 12th class students in here. So I would just want to share with you why should it all we study chemistry? No, why is it important and how is it important? Because I'm sure for most of you it would mean basically cramming formulas, equations, mechanisms. And that when you say it like that, it obviously sounds very boring and not at all interesting, right? But honestly, if you ask me, not that because I'm a chemist, so I'm biased, but whatever you do in your daily routine, right from the time when you wake up in the morning till you sleep, actually involves chemistry. When you wake up, you brush your teeth, your toothpaste is a chemical compound, you get ready and mama cooks breakfast for you. That involves chemistry. The sunscreen, the cosmetics that you apply when you go out of your home, that they are chemistry formulations. And basically your medicines and everything. And nowadays, what is most important when you leave home? That is your smartphone and your sanitizer. And both of them would not have been possible without chemistry, right? So basically, whether you like it or you don't like it, chemistry is something that is involved everywhere in your day-to-day life. You face it. So it is. So that is why that is how it contributes to community, health, environment, medicine, and so on. So okay. So what do I say? Is chemistry is omnipresent. God is omnipresent. Chemistry is omnipresent. On a lighter note. Okay. So before we talk of chemistry, let's try to remember two people who actually, started these major, let's say, a major branch of science. So Antoine Laurent Lavoisier, he is remembered as father of modern chemistry, and he is the one who is responsible for discovery of oxygen and how oxygen is important in combustion and respiration. And he also established the law of conservation of mass. I'm sure whether you remember it right now or not, but all of you have studied it. And for us in India, Acharya P.C. Ray, Prafulla Chandra Ray, he is remembered and known as father of Indian chemistry. He is the founder of India's first pharmaceutical company, a very brilliant organic chemist behind the chemistry of various known sulfur and coordination compound. In fact, he was not just a chemist, because, as we say that chemistry is involved in all the spheres of life. He was actually an all-in-one personality. He was a scientist, an educationist, a philanthropist, an entrepreneur, and historian. And he believed that the national growth is actually dependent on industrial, social, scientific, and the educational reforms. Okay, so today morning, we're talking about looking for a career in chemistry. That is basically the question we would be answering in next 40-45 minutes. Okay. Before that, let me just, I wish this was an offline talk where we could have interacted more, but let me just put up a question. What is a career and what is a job? Okay. Job, if you see the definition for the job in Oxford Dictionary, it says They are the activities or the tasks that are performed to earn livelihood. So basically, they define kind of a short-term thing. What should I do to earn money, right? Well, what is a career? Career is basically job and much more. They're more long-term. They're about learning, experience. Of course, they involve good salary, but along with that, they involve job satisfaction, exciting profile you should have, opportunity to grow and learn, opportunity to contribute to the betterment of the society. See, all of us are ultimately the parts of society, isn't it? So, a career should give you an opportunity for skill development, growth, and one thing which we all crave for is whether we admit it or not is recognition and respect for our work, isn't it? So, let us try to see how chemistry covers all this, and let us try to structure this thing by asking few questions. Is it worth making a career in chemistry or science in general? Let's talk about science also, okay? Which actually what means is, if I ask a 11th kid and if I simplify this question for you is, should I really do chemistry? Should I really do science? What are the careers or career options in chemistry? Okay, I agree I should do science and chemistry, but what if I decide, then what are the options that are available to me? And science is basically progress by research. So if I also think that I can pursue research in chemistry, if I like it, then how should I go about it? So let's try to answer these questions in a systematic manner. First one, is it worth to make a career in chemistry and science? Okay. So basically, chemistry is right now. See, if I talk from a researcher's point of view, for research you need funds, okay. And if I talk from a humanitarian view, whatever we do has to ultimately lead to the betterment of our society, betterment of our of the mankind. So, what does this involve? This involves problem solving in food, shelter, clothing, energy, health, and a clean environment. Okay. And now chemistry is involved in all of this. So obviously, if you're doing good chemistry, if you understand it, that means there is a demand for you. Okay. Other than that, once you are doing, some of you for last 2 years, it has been little difficult for you to do experiments and all, practicals and all. But maybe you can think, if you're doing experiments, what all does that particular setup teaches you? Your scientific and numerical skills, your curiosity, why should I do this thing? Organization, how to organize my work, attention to the details, I'm getting this observation, I should be very attentive to each and every observation. Then the experiments might fail. It teaches you patience and determination. So you just can't start any problem on its own. You have to research it. So it teaches you how to research the problems. Adaptability. My experiment is not working. Let me just take another route. Analytical skill. I have got the observation. How do I analyze it? And more than that, communication skill, because ultimately you have to communicate your results. Now, if you ask me, whatever words I just said, basically they are an essential skill set, that any employer would look into a good employee. Or if you ask me, now that I've already spent 20 years after my MSc, I would say this is also the essential skill set that helps you in leading a good life. So once you have all this, obviously this increases the prospects of your employability. Okay, let's play a little game. Try to identify these three gentlemen. Take few seconds and see if you know them. You might know them, you might have a very good general knowledge, but chances are you might not know them also. Okay, now tell me whether you know these guys. Definitely, if not three, one or two, or in fact three also you would be able to identify. Okay, so now the gentlemen whose photographs are there in the top row, they are the very important people. They have been the leaders of the state. The first one, Armand Falliers, he was the president of France in 1911, but it was a little difficult to recognize him. But below him, it is Madame Marie Curie, who won 2 Nobel Prizes, both in physics and chemistry, and we know her. Friedrich Ebert, he was the president of Germany in 1921, and during the same year, Albert Einstein won Nobel Prize in Physics in 1921. We know Albert Einstein. Who doesn't know Albert Einstein actually? But little difficult to recognize Friedrich Ebert, right? And similarly, Edward Wood was the Viceroy of India in 1930. Probability we might not recognize his photograph, but we will surely recognize Sir C.V. Raman, who got Nobel Prize in the same year. Same year, same geography. People who are scientists, there's a possibility that you know them more. So was I wrong when I said that science is one profession that increases the chances of your respect, recognition in the field if you do good work? Okay, now just because we have young students here among us, those were the people who were Nobel Prize winner. Okay, let me give you some contemporary fun facts. There are few scientists who have forayed into politics and they have made huge career for themselves. Angela Merkel, for possibilities, you have heard of her. She was the Chancellor of Germany, just retired last year in 2021. First woman and second longest serving Chancellor of Germany. And she is a doctor in quantum chemistry. I mean, no physical, inorganic, which all of us claim we can understand. Quantum chemistry, of course, is a little specialized field. So see, she was a PhD in quantum chemistry and went on to become Chancellor of Germany and carved such a good career for herself and respect. Brian Eddon, he was a professor at Salford University. When he decided he could use his skill set that he has gained as a policy maker. So he became member of parliament in UK. He was a member of Science and Technology Select Committee, chairman, all-party group on chemical industry, and there are many more examples. And honestly, I have come to know of it only while I was working on this talk for interacting with you people. So this is really fascinating. Now, why is it that the chemists who are going to politics, they are doing very well in politics as well? I mean, it's not a rocket science if you think about this. What do politicians aim to achieve? Basically, what do policymakers aim to achieve? They want to go attain the economic, social, and environmental well-being of the people, of their nation, of their community. And chemists who actually understand this thing, who actually aim to provide the solutions to these issues of global concern, they obviously, when they go into policy making, obviously they would, there's a high probability that they would make a good career out of it. But a fun thing, is it possible for a practicing politician to get back to science or chemistry? That, I suppose, you would agree with me, would be a little difficult, isn't it? Okay. Now, how the scientific discoveries, let's start from the past, have actually led to the betterment of human life. Let's see one or two case studies. Okay. So, I hope all of you have heard of cathode ray experiment. You might not remember it right now, but if I tell you cathode ray experiments were actually responsible for the discovery of electron. So let us see how that, only this particular thing, how this led to some events, some inventions, discoveries that led to betterment of human life and led to advancement in the modern society. Okay. So the cathode ray tube experiment led to discovery of electron in 1897. And that cathode ray tube was also responsible for invention of television, that with CRT monitor. I'm sure all of you, the students I'm talking about who are present today would not know what a CRT TV looks like, but I'm sure many of your teachers would recognize this. I remember when I was 10 or 11, we had this TV at our home. And then it led to ultimately development of image monitors of different types, which we now see. Okay. Now, this discovery of electron was responsible for us understanding mechanisms like electricity, magnetism, thermal conductivity, so on and so forth. And then the discovery of electron was followed by discovery of nucleus in 1911. Going forth, cathode ray tube led to the discovery of electrons, we just saw on the previous slides. They also led to the discovery of X-rays in 1895. So invention of X-ray machines led to the invention of CT scanners. All of us know doctors now and then, every time they ask us to go for a CT scan, and that has solved so much of, problem of imaging of any issue inside the body. Then X-rays could lead to invention of X-ray telescope, with which we can understand and study the celestial bodies like black holes, supernova, etc. Then X-rays also led to the development and the advancement in X-ray crystallography, which helped us understanding the structure of biomolecules which are important to our life, like DNA. So DNA structure could be solved, and that led to important techniques such as discovery of DNA fingerprinting. So how one thing is basically leading into another. Okay. So electrons were discovered, that led to better understanding and understanding of how the structure of atom itself and atomic nucleus could be. And once we had the knowledge of atomic nucleus, that led to our understanding of phenomena such as radioactivity, that led to nuclear power, which is one of the clean sources of energy today. Then gamma, the nuclear radiation such as gamma, they were used for medical imaging, all of us know. Then atomic nucleus was also used for advancements for augmenting national defense. Okay, so how one thing leads into another, how the simple cathode ray tube led let's say what effect we call it, the dominoes effect, wherein you could one after another different discoveries were made, but the basis was a humble cathode ray tube. This is how science leads to the advancement of society. Okay, what impact chemistry? That was about general science and chemistry together, but what impact chemistry has had and passed on human life? Okay, so all of you know ionic bond, covalent bond, hydrogen bonds, right? So covalent bond was actually that understanding was given by Jean Lewis, whose photograph you see here. He wrote a famous article in 1916 where he discussed this concept of sharing of electrons between atoms. Now, this concept of sharing of electron or the covalent bond is behind understanding the structure of diamond and graphite, which were the only two allotropes of carbons known to us way back. Now, down the line, more than 100 years, it was in 1960 when Lewis invoked this concept of covalent bonding. We have different other allotropes of carbon known to us: fullerene, graphene, carbon nanotube. I understand these could be a little, probably you would have heard about it, probably you would not have heard about it. But these are the materials that are like the cutting edge, front running materials for various applications, because they have excellent electronic conductivity, they have immense mechanical strength. So they have applications right from high-end clothing to, applications in your bulletproof materials and structured materials for space vehicles and so on. So this is how basic fundamentals led to the advancement in materials. Okay, a major problem right from very early period in humankind has been ensuring food security. So what happened in early 20th century, the population was booming because by the grace of God, there were good medical facilities. There was advancement in medical field that led to the increase in human life. But that increasing population had to be fed. Okay, and then scientists realized that once you feed the nitrogen containing compound to your crops, they give good productivity. That means fertilizers were needed. But for making fertilizers, we needed ammonia. Nitrogen containing fertilizers, we needed ammonia. This is where Haber's discovery, wherein he showed that nitrogen from the air can be made to react with hydrogen from the natural gas, and you can make ammonia at laboratory scale, and that can be used for fertilizers in addition to other application. So this is Fritz Haber demonstrated it, and this discovery, if you ask me, whatever I have read about it, it is counted as one of the most important discoveries, most important chemical reactions in last 200 years. Now the thing is, this required temperatures of the order of 400 and very high pressure, 200 atmosphere. You can understand if I tell you, atmospheric pressure of our air right now we're sitting in is 1 atmosphere. Now here you need 200 atmosphere of pressure. That is still easy to, not easy, but that can be done at laboratory scale. So while Fritz Haber got the Nobel Prize for this chemical reaction, Carl Bosch got the Nobel Prize for his contribution for generating such high pressures and for scaling up at large scale. So this led to, in fact, this particular process itself, because it helps in rapid growth of food chain and prevented billions of people from starving to death. For this particular reason, 3 Nobel Prize were given only for this particular process to Fritz Haber, to Carl Bosch, and Gerhard Ertl. Okay, healthcare. I mean, right now you get a cut, a little deeper cut. So what does doctor give you? Doctor actually does the bandage and all, and they give you antibiotics. The first group of antibiotics that were discovered by was penicillin. Okay, Alexander Fleming discovered it, and such is the importance of this discovery that he has been labeled as one of the 100 most influential people of 20th century. Then Alexander Fleming actually discovered penicillin, but to get it as a drug, chemists from Oxford, H. Florey and E.B. Chain, they contributed for development of penicillin as a drug. So they shared the Nobel Prize for this. Dorothy Mary Crawford, such important was this chemical formula that only for deriving its structure, Dorothy Mary Crawford got the Nobel Prize in 1964. And now all of us know how we are given antibiotics for every simple disease that is called, which actually earlier doctors did not know what to do with that. Once you had an infection and the infection is spreading, they could do nothing but just wait, right? So penicillin again is a very important contribution of chemists to the society. Similarly, aspirin. I won't talk of aspirin. All of us, we have a headache, little bit of inconvenience, we take aspirin, and the formula behind this aspirin is actually acetyl salicylic acid, which was synthesized by Felix Hoffman in the lab. Okay. Now, coming about traditional chemistry and the new branches of chemistry. Traditionally, what do we know about chemistry? We say we have chemistry, we have physical chemistry, we have organic chemistry, we have analytical, and we have inorganic, right? But nowadays, and if you ask anybody who is doing research, once you go at that research level, these boundaries between whether it is chemistry or it is physics or it is biology, or for that matter, even if it is engineering, that kind of starts fading away, because making a discovery is one thing in the lab, and getting it into the lab, outside in the society, in the market, in a usable form involves lot many fields. So now there is an evolution of many new subjects. The area that I work in, material science, when I do material science, basically I'm not doing just chemistry. I'm utilizing both the concepts of chemistry and physics. When I do, let's say we work on bioprobes, which are actually chemical molecule, but have bio application. So I'm working in biochemistry. Hell, what with the engineering? You have chemical engineering, you have biochemical engineering, biotechnological engineering. So basically the fusion of various subjects has led to many exciting new subjects and the newer discoveries, which are still important for the society. I'll give you a very good, very interesting example. He is Professor Venkatraman Ramakrishnan. He won Nobel Prize in 2009. Now, if you study about this gentleman, he studied physics at Baroda, did his PhD also in physics. He worked on ribosomes at Yale University, which is a biological topic, right? But he won his Nobel Prize in chemistry for studies of the structure and function of ribosome. I mean, what better example than the convolution of subject and knowledge you can look at? A person who has studied everything, who has done something in physics and biology, but ultimately has been recognized in chemistry, shows that boundary actually fade away when you reach at that level. Okay, some interesting example of the liaison between different subjects which have brought greatest discovery. We just talked about the Haber-Bosch process. So Fritz Haber was a chemist. He discovered that reaction, but Carl Bosch was a chemical engineer who scaled that up. Okay, penicillin discovered by Alexander Fleming. He was a biologist, Upscaled by engineer Hasper Kane, John McKean. Hasper Kane was a chemist, John McKean was a chemical engineer, and Margaret Russo was the first woman chemical engineer from MIT, USA. Polyethylene. Polyethylene we use nowadays, of course, we have been asked to not use polyethylene that much, but all of us would agree that this has been like one invention that has, kind of brought revolution in the society. So it was discovered by Reginald Gibson, Michael Perrin, and Eric Fawcett. They were chemists, and scaled up by Dermot Manning, who was actually a chemical engineer. What interesting confusions of science you can see here, isn't it? Okay, so various breakthroughs that have been in last 25 years in terms of high-end material also. For example, superconductors, fullerenes, nanotubes, nanomaterials, mesoporous solid, an unprecedented boom has been witnessed in last 25 years, and chemistry has played a central role in all of these discoveries. So basically, till now, probably you have understood what I want to say is that chemistry contributes to so many fields. Polymers, they are chemical molecule, drugs and dyes, materials chemistry, biomaterial, energy devices, nuclear, where and where not actually. Chemistry is omnipresent. Okay, now, I have probably understood that chemistry is important. It actually led to advancement in society. But what are the options available to me? So let us just talk about those, okay? So various options that you can actually look at is in government sector, where they need chemists, in industries and private sector, academics and teaching. If you like teaching, I think this is probably the most noble profession in the world, and entrepreneurship or startups. Okay, let's just what my objective here, and which is not possible also to give you each and everything, but just lead you, just give you an eye opener in various sectors, where you can look out for yourself. Nowadays, all of you are so much tech savvy that once you are shown the way, you would be able to find out so many things for yourself. So government sector, geochemists. This exam, geochemists are hired for studying the distribution of various chemicals, oils into soil and water, how they move into the soil and water, their movement, composition of various fossil fuel deposits, then analyze the age, nature, and component of rock and minerals, etc. And their research, whatever they do, the study that they do, is actually used for guiding oil exploration, improvement of water quality, and develop plans to clean up toxic waste site. And then, of course, and once they are experienced, they can teach and lecture on specific areas. They can go for freelancing and consultancy work also with big industries. So when you join as geochemist, you get an opportunity to work with specialized instruments such as high pressure liquid chromatography, electron microscopy, mass spectrometry. And there are opportunities that exist with oil and gas company, environmental consultancy, and you get a lot of research facility also. Qualification is MSc or in chemistry or applied chemistry, and the salary is level 10 of government pay matrix. Okay, ONGC, Oil and Natural Gas Corporation. So here the chemists are required in the drilling operation so that they can prepare, test, and maintain the drilling fluids. And they're posted in various production platform, obviously various installation. And main role is the quality control of crude oil, gas, prior to and after processing. And then ONGC also has various R&D laboratories where R&D scope also exists. Qualification is again a first class in MSc in chemistry. Then you can have a valid GATE score also. You can give GATE exam, which is followed by interview. And salary is, of course, given that nowadays comparison, it's a pretty handsome salary with various perks as well. Okay. DRDO. Now, DRDO employs bright, qualified, and competent candidates initially as scientist B. These are the ranking. If you want, you can just explore further what does these letters mean. Okay, so here the chemists are required in R&D for ammunition, metallurgical analysis, for food sciences, fire retardants, bulletproof jackets, etc., glass technology, Then analysis of aviation fuel. Yes, that's very interesting. Coating technologies. We're developing heat resistant, weather resistant coatings and all. Again, you require a master's in chemistry, a valid gate score, if not written, valid gate score in chemistry followed by interview. This is again, the salary is equivalent to what was shown by your this thing, ONGC and others, with other benefits and perks. ISRO. Now, all of you know ISRO has made us real proud in last 2-3 years. So here the chemists are required for quality control of solid propellants used in PSLV and GSLV. They're also required, the samples are collected from celestial bodies like moon and their mineralogy is done. So their chemists are needed. And chemists are needed for quality control of adhesive, insulation and coating material used in all the equipments used in ISRO. So there you can join as scientific officer or also as scientific assistant. The salary is again level 10. It is a group A gazetted job. Emoluments are close to 80,000 per month. But of course, this is give and take plus minus. Okay. Now my Department of Atomic Energy. In Department of Atomic Energy, there are various constituents units. First of all, you know, is in your home state, that is Bhabha Atomic Research Center. In IGCAR, Indira Gandhi Center for Atomic Research, it is in Kalpakkam, Tamil Nadu. RRCAT in Indore, this basically works on various advanced accelerators. So we have nuclear power plant, NPCIL takes care of that. That is also one of the constituent of Department of Atomic Energy. Heavy Water Board, several other DAE-aided units are there like TIFR, which is in Mumbai only, Saha Institute of Nuclear Physics, Harishchandra Research Institute. And then we have in Vizag, Vishakhapatnam, a new campus that has come up, BARC, that is called BARC Vizag. Okay. Now that is this beautiful scenery is my institute. Okay. So in BARC, we have, now BARC, you know, one interesting thing is in some other organization, if you're a chemist, you would only go to few particular division which are doing chemistry. In BARC, chemists are required in all the groups because everybody needs chemistry for some or the other thing. So we have various groups like physics group, chemistry group, radiochemistry and isotope, nuclear fuels, materials, even biosciences and nuclear engineering group. They also need chemists, and chemists are posted according to wherever the requirement comes from. Okay, so how to join DA? Okay, now all of us know Dr. Homi Jahangir Bhabha, the visionary. He set up the very prestigious BARC training school in 1956. He always thought that technology makes it possible, you know, to do different things. But ultimately, to make technology happen, we need bright people. So with that vision, he started BARC training school. And for this, the qualification that is needed is first class master's degree in chemistry. We take scientist trainees in different disciplines, but now today I would be talking only of chemistry. So, and you can have a valid gate score in chemistry. So either you can give written exam and you will be shortlisted and called for interview, or you have a gate score and based on the minimum gate score that would be set up for that particular year, you would be called for interview. But either ways, whether you come through written exam or through your valid gate score, you'll have to come for the interview. Okay. And then once you clear the interview, you are inducted as trainee scientific officers and you're given 1 year orientation course in nuclear science and engineering. And after completion of that course, you are absorbed as a scientific officer C in various DA units. It is a group A job of Government of India. And depending on where the requirements have come from, you will be sent there. Again, the starting level is level 10. That is the 7th pay, according to 7th pay commission, level 10 of pay matrix you are inducted in. And the emoluments is what you see on screen. Again, plus and minus something. Okay. So that was one way through BRC training school. For that, you required MSc. If you want to join after BSc or if we talk of other discipline in engineering, basically, then there is another written exam and interview, and that was called BRC training school. This is called CAT 1 training program. And once you clear the Cat 1 training program, again, this is also a 1-year orientation course. After you are selected, you are absorbed as scientific assistants, which is a Group B officer in Government of India. But the best part is, if you're bright, if you work hard, there is a track change option that even if you join as assistant, you can track change and go to technical officer or scientific officer, which is again the Group A job. Okay. And even for the people who join after MSc and through BRC training school, there is an opportunity for higher studies throughout your life post joining. You can do PhD. If you joined after BSc, you can do your MSc followed by PhD and go for postdoctoral assignments also within India and abroad. So a lot of options are there once you are, dedicated and passionate towards doing stuff. Okay, I'll talk about this university collaboration later. Then there's another entry scheme. Suppose you've done PhD and after PhD you want to join BRC. Then there is something called KS Krishnan Fellowship. It is a board of research in nuclear science scheme. They call twice a year. Interviews are held after shortlisting. And on 1 year, you are on probation. And after 1 year, you are absorbed as scientific, the BRC training school trainees who are joining at SOC. The people who come after PhD and under KS Krishnan Fellowship, they are absorbed as either D or E, depending upon the performance in the interview and their 1 year probation period. Now, other government organizations that look out for chemists are Bureau of Industry, Indian Standards, Department of Chemical and Petrochemical has got many companies such as Hindustan Organic Chemical Limited, Hindustan Fluorocarbons, Hindustan Insecticides. They have requirements for chemists. Then Department of Pharmaceuticals, then FSSAI, which is Food Safety and Standard Authorities, Patent Office. I mean, this is one field which you should look at, is patenting and copywriting. So list is not exhaustive, but just keep these things with you. It will give you a direction to search for when you are looking out for various options. Okay. Then industries. In private sector, you have chemical, pharma, renewable energies coming up in a very big way. Agro, paints, petroleum. So, various chemical industry you can broadly classify it as bulk chemical, specialty chemical, agro, petro, polymers, fertilizers, pharmaceutical, and food additive. Now, India, you should just know this. See, how do we decide that this field is upcoming? When government is ready to invest in that field, they understand the importance. So, India ranks 6th in the world in chemical sales and contribute 3% to the global chemical industry. Basically, we are making more than 80,000 commercial products. Government of India has recognized this and forecast to increase share of chemical sector to 25% of GDP by 2025. So various chemical industry, private Indian companies that hire chemists are Dabur, HLL, Ranbaxy, Dr. Reddy's Laboratories, Reliance. Reliance has got many sub companies which hire chemists. Okay. Now, I also would want to give you some idea where you can search in some non-traditional jobs that a chemist can look for and train for. Forensic sciences. You know what is forensic sciences? It is basically to identify and quantify and also evaluate unknown items at the crime scene and do the laboratory-based analysis of the evidence. Okay. So various companies that would hire you for this particular specialty are Directorate of Forensic Sciences, Intelligence Bureau, CBI, then Defense and Army. Private detective agencies would be very keen. Hospitals, Quality Control Bureau, law firms, because they need to look into these things, and so on. Then after forensic sciences, toxicology. Toxicology is basically to understand safety and biological effect of various chemicals like drugs, chemical, other agents and substances on living organism. That is toxicology. So once you've trained into this particular field as a chemist, you can be hired by various industries, which are chemical industry, food, pharmaceutical, biotech, environment related industries, teaching and research. Of course, now there are many universities which are coming up with toxicology oriented specialized courses. Then government organizations that deal with regulation of chemical usage would need toxicologists. Perfumery, another very interesting field. Now this involves R&D with different kind of scents, development of various formulas, from automobile air fresheners to antiperspirants to cleaning laundry, personal care products. So these, and I believe that they should be lucrative because not many people are actually available in these kind of areas. Chem informatics. Chem informatics is basically the fusion of chemistry and information technology. So what happens is, suppose there are many people doing research on a particular kind of drug. They are working on various variants of that drug. They'll keep on generating data. And some 10 people have done the thing and the 11th person wants to take it up. So it will be very helpful for him to understand what those 10 people did and what were their results. So what chem informatics does is the chemical information that is being generated, that is stored, managed, and chemical problems are solved with the help of IT, information technology. Sometimes certain softwares are there, they feed in the present data and give you the information. Okay, this thing probably won't be possible, so don't go into it. Or this area looks in this particular area, based on the earlier generated data, this looks more promising. So those kind of things are taken care of with the help of chem informatics. And chemical health and safety. Health and safety, believe me, is has been actually made mandatory for all the organization. It is the fusion of chemistry and public safety. The job is maintaining inventory, training others in safe use of chemicals, responding to emergencies, performing laboratory inspection. We have regular laboratory inspection, to be very honest, risk assessment of the activities involving chemicals, and investigating accidents and injuries in which chemicals were involved. The last for today, for now, is science policy analyst. Now, this I came up very recently across with, is basically people who have studied in science, but they go into policy making. Okay. Now, generally, the policymakers are the people who are not trained in science. So there occurs a gap between how to apply this, how to understand what is happening, and use that for the advancement and application for larger benefit of society. So this particular field is basically to bridge the gap between scientists and policymakers. This, I think, would be one which could be very interesting area to develop yourself in, if you like it, of course. Okay. So, okay, that was about government sector, private sector, and some non-traditional sources. But can I become an entrepreneur by pursuing chemistry? Can I do my own business by using chemistry? Yes, and please, you should do this. Everybody should not look out for seeking employment by some employer. Be an employer yourself. Create employment, what our respectable Prime Minister says in the spirit of Atmanirbhar Bharat. Entrepreneurship is becoming a very lucrative thing if you really are smart enough in understanding of chemistry. There are many leading startups worldwide in chemistry, which are dealing with the molecule drugs for targeting RNA and antibacterial, antifungicides for agriculture industry. Then renewables, green is such a buzzword in today's society. Bio-based, biodegradable polymers for personal care and other application. Ecovia Renewables does that. You can look out for these startups and read about their stories. Then even in India, now these are worldwide, these are abroad. In India also, there is a step change in the mindset of researchers. They want to translate whatever research has been done into the products that can benefit the society. Now, this particular statement was made by Professor S. Sivaram. He was director of NCL Pune. And then in the next decade or two, they say that we can see an enormous amount of translational research because the people are becoming smart. They are realizing that there are huge opportunities to grow, and even small products can find some niche and use. So large number of startups as spin-offs of research are becoming reality in India. Okay, and government is supporting it. That's the best part, Ambition for this translational means translating from lab-based research to land. What the Prime Minister Narendra Modi had coined this term some 4 or 5 years ago. He said, bring the research from lab to land. Okay, So that kind is supported by India's Department of Biotechnology and DST. There are some specific initiatives also, like Atal Innovation Mission, Startup India, they support entrepreneurship. Then DST has set up technical research centers in leading university where they give generous grants. Then there are ventures like Venture. It is named Venture. It is a government-sponsored incubation center in Pune. It already has 45 startups and it is mentoring several others. Then several private players other than government, Kotak Investment, CCAM, they are also interesting and they're actually investing in science-based startups. A few examples in India also. There are many actually. Honestly, yesterday I was reading about it, and there are more than 500 in Indian space, but I've just listed 4 of them, for the paucity of time. InnoDI Water Technologies. This is Professor T. Pradeep IIT Madras, his venture. They provide water filter to provide safe drinking water, and it doesn't use any chemicals and it uses very low power. It uses a process, if you want to read about it, which is called capacitive deionization. Then Professor Govind Raju, he is a chemist in JNCSR, and Meher Prakash, he is a physicist. So they actually have come up with the small molecular probes, suppose you want to investigate tumor or any other development in your body. So these probes can go there, and because they're fluorescent, they're lighting, you can use them for imaging. Then Breathe Applied Sciences has been started by Peter Sebastian, Umesh Wagmare, and Rakshit Pelul. 2 of them I know are in IIC Bangalore. This is for products for cleaning up carbon emissions. Then FruWash, Professor H.M. Chawla in IIT Delhi. He taught me also. He has come up with various sustainable solutions with which if you wash your fruits and vegetables, they can you can increase their shelf life from 3 days to as long as 6 weeks, which is a kind of 1.5 months. So simple ideas, how you think it can translate into some kind of business venture, whether it would have people who will take it. So, it's your age. Start thinking about the thing. It's not that you will one day immediately, today you've thought about it and tomorrow you have to do it. Think about these things and that thought process will lead to something concrete. Okay, now what are the opportunities to pursue research in India? What are the various fellowships that are available to you? To start with, I'll talk about the younger kids. Summer fellowships are given by science academies and they're given to bright students and also to motivated teachers, honestly, to work with the people who are the fellows of science academies and are placed in various institutes in India. You can go and work with them for 2 to 3 months. Normally, the applications they cover your travel and living expenses. The fellowships are given. The applications are called in November, December. Selection sometimes is announced in February, March, and you can go for 2 to 3 months. This basically would get you a flavor of how the research works, how the people think, how the big organizations run, other than doing some small problem, which will also give you some on-hand experience. Okay, now surely you know about it. These are the centers of excellence for doing your higher studies in India, which involve government has now opened many new IITs and ISERs. So yeah, these are the institutes you should keep looking at because they keep on doling out information for applications. Okay, now this is Homi Bhabha National Institute. That is the Department of Atomic Energies deemed university. Again, all the constituent units which come under DAE are also the CIs of Homi Bhabha National Institute. You can do your PhD, MSc, MTech, then some specialized courses, which of course will have many takers like diploma in radiation medicine, diploma in medical radioisotope techniques. So Homi Bhabha National Institute grants you degree and you do your research in any one of the institute that is listed on left-hand side of the screen. Okay. Then CSIR labs. There are 38 CSIR labs and they are doing excellent research. And CSIR is actually committed towards converting its research into, technologies that see market one day. And various financial help research fellowships that are available to you is one is National Eligibility Test. Most of you would know. UGC conducts this exam twice a year For the award of Junior Research Fellowship, they select roughly 2,000 candidates by CSIR and UGC. And fellowship, if you get the JRF ship, the fellowship is 31,000 plus HRA, which is decent considering you're actually studying. After 2 years, you become a senior research fellow and your fellowship increases. And if you're doing a postdoc, it is 54K plus HRA. Then graduate aptitude training examination, if you give this exam, they normally give the fellowship for MTechs to the best of my knowledge, but of late I've heard that in some fields they also sponsor PhD. Then this thing is pretty new. Prime Minister's Research Fellow Scheme. This, if I'm not wrong, was launched in 21 only. Now here, suppose you've already joined PhD in some institution, you can apply for this particular scheme. And this has been started specifically for improving the quality of research. And the fellowships here are super attractive for people who are doing PhD. For 2 years, it is 70,000. 1 year, it is 75, and then 80,000 for other 2 years. In addition to that, you get a research grant of 2 lakhs per year. This particular thing is this is a website link. Otherwise, also, I'm sorry, you can search for Prime Minister's Research Fellow Scheme and you'll get all the details. Then BRC gives some PhD fellowships. In fact, in another month or so, you can look out for our advertisement. Under BRC HBNI PhD scheme, applications are invited, shortlisting is done, followed by interview. And the fellowship, financial fellowship, is as per the UGC norms. Okay. Now, want to do PhD, right? I just would want to tell you that once you actually start, because research is a different ball game altogether. So if you really want to do research, you think and decide, yes, I want to do it. Choose your mentor. Look out for people who are working in that area and research topic. Identify the issues that people are really working on. What actually affects the society. Then once you have studied various things that are worked upon, then you identify whether you like this, whether you like theoretical chemistry, or you would want to dirty up your hand and do experiments. Analyze your strong and weak points. Pick up a problem that will really make some difference to you, make you happy, give you satisfaction, and best if it makes some difference. Pursue it, please. And all these things will help you learn new research skill, writing manuscript, writing research proposal. What it does is, it actually enhances your communication skill, which I think is most important in any area of research career that you want to pursue. And then if you do good research, publish good. Because good publication is ultimately that comes on your CV. And for post-PhD, once you're already done your PhD, these are 2 very handsome fellowships that are given by Government of India. One is NPDF, that is National Postdoctoral Fellow, and DST Inspire Fellowship. Very competitive fellowships. NPDF is for 2 years. It is 55K plus HRA. In addition to that, you get 2 lakh contingency and 1 lakh overheads. DST Inspire is 5 year and very handsome emoluments, close to 1.25 lakh. In addition, 7 lakh contingency. And also there is an option that during these 5 years also you can go for 18 months study or research leave to other countries if permissible. And but these 2 are highly competitive. So requirement is a PhD with good publications and a good research proposal. Okay. See, chemistry, what are the present and future challenges? Whatever we do, we actually has to see. Of course, later on in your life, maybe you will have some other obligations and you choose not to explore so much. But at your age, when you're growing, when the world is wide open for you, look out for things that change, What are the challenges that world is facing now? Even UN has identified few things like zero hunger, good health, clean water, clean energy, combating climate change, responsible consumption, industry innovation and infrastructure, and a chemist can contribute to all of them. With chemistry, we definitely can. So, and these are the mega projects which you as a chemist can contribute to achieve the goals that I showed on the last slide. Efficient harnessing of solar energy. Then once you've harnessed this energy, how would you store it and convert it? Then hydrogen production, carbon sequestration for good environment, nuclear energy, safe drinking water, smart materials, and whatnot. Once you start researching yourself, you will know what are the major fields. But of course, these things will help you as a guideline. Now, at the end, I have spent some 20 years after my MSc. So I think I'm a little more experienced than you. So probably there's certain things that I would like to tell you. Now, these are not copied from anywhere. This is what I have learned. And I really want to tell this to the students whenever I would meet them. You know what? Introspect and look forward to meaning in what you want to do. That will give you a lot of satisfaction at the end of the day. Look forward to enriching the life, yours as well as people around you. And most important, stop bothering about small things. This friend of mine told me that teacher scolded me for that, this thing happened. So what happens is it excludes negativity, it creates space in your mind for doing better things, and it saves a lot of time for constructive things. Otherwise, mind has only that much space. Day has only that much time. It will be gone in that. So maybe right now this might sound like a preaching, but just think about it for a few minutes after the talk, and you'll see that it is easy to do, difficult to practice, of course, easy to say, but once you are able to take these things in, they will help. And very important for a student or for anybody, but imbibe it right from when you're very young. Once you decide that I have to do this, please no half-hearted measures. What happens is, now suppose you fail, okay, at the end of that work. It is okay to fail, but you would not know that you failed because your strategy was wrong, because your problem was wrong, or because you didn't give it your full. Okay, so from your side, it has to be no half-hearted measure. And whatever you do in life, do little, but do it with passion. Why? Because when you're doing with passion and when you fail, you will still have the motivation enough to get up and do it again. And things appear difficult. Most of the time, somebody tells me, oh God, this is so difficult. Things are difficult. But take a minute, absorb it, and tell yourself it is difficult, but it is doable almost every time. Okay? Make an attempt. Don't leave it without attempting. Last and very important thing is, you would love to do so many things. You might get a career of your choice. You might not get a career of your choice. So it is excellent if you get to do what you like. That is what dreams are made of. But it is equally important to like what you do. Okay. So the things that are marked in red, the third one and the last one is what were told to me by my mentor, who is now Director Chemistry Group, Professor A.K. Tyagi, when I joined. And I have really felt I'm still trying to imbibe them. There are times when I kind of crib that I don't like this job, but I try to remember this and do this, and it has helped me. So what ultimately helps us in life is right attitude, hard work, and very good time management. If you follow these three things, I have absolutely no doubt that whatever you do in life, you'll be happy, successful, satisfied. Okay. So, there is this very famous book called What They Don't Teach You at Harvard Business School. So there is a statement. They say, if you work with your hand, that's labor. If you work with your hand and employ your head, that's skill. If you work with your hand, employ your head and do it with your heart. That is, do it with passion. It becomes art. So make everything you do art and just not labor. Okay. So your goal has to be pursuit of good science, and it shall automatically lead to a very successful career and an enriched life. I wish you all a very best for this. You believe in yourself, you challenge the limits and be successful. God bless. Thank you. Thank you.
Thank you so much, ma'am. It was a great session. We have gained very important information today from you, ma'am. Now, I would like to call upon Harshada Niju, ma'am, to continue with the question and answer session.
Thank you, Aditi. Thank you, ma'am, for such a wonderful session. You have given all the possible careers that the students can look for in chemistry. And I myself learned a lot from today's session, that what else I can, other than usually with what we tell students, other than that, we can actually tell students we have learned today from you. Thank you so much, ma'am.
Thank you.
Yeah, I would like to ask students if they have any questions, they can either ask
Ma'am?
box. Yes, Aditi.
Ma'am, how can we pursue forensic science through this?
Yeah, Aditi, I went through this so that if you ask me, basically, I think the possibilities after your graduation, you can do some specialized courses in forensic science, and otherwise, also, I think there are nowadays graduation and post graduation available in forensic science itself. So, do some search on this. But I think after your BSc in chemistry, a post graduation in forensic science is definitely possible.
Okay, thank you, ma'am.
Ma'am, we have one question in the chat box
Okay.
asked by Abdul Sheikh.
Hmm.
He's asking about, ma'am, what kind of study we have to face in quantum chemistry?
Okay. So Abdul, quantum chemistry is like I'll give you an example. Okay. Suppose, but nowadays you know that there is a lot of thing about solar energy, harnessing solar energy and storing it. Okay. So I have designed a material. Now my material, basically what happens in the solar cell, all your energy from the sun that is trapped, that is taken up, and that by the means of photovoltaic devices is converted into current. Okay. Now, normal material, now the solar spectrum, if you remember, has got light from IR, UV, and visible. And your photovoltaic material, which is taking up that energy and converting into current, has only that much band gap so that it can utilize only a part of the solar spectrum. So efficiency is less. Now, suppose I want to improve the efficiency. What can I do? I can tune my band gap in such a way so that the entire solar spectrum or a lot of it is taken into it. Okay. Now, there are two ways of doing it. Abdul, I take so many compounds, synthesize them, and then test each of them, which is fine, which is the best way. But the quantum chemist or the theoretical chemist, what they can do is they can imaginary, suppose I give them a composition. Okay, you take these and these elements. What they do is take these and these elements, mix them. Now, suppose such an imaginary compound is there, it will have this kind of band gap and it will absorb this. So this is what theoretical chemists do. They provide you a platform to work upon. Theoretically, this should be the band gap. Theoretically, this seems to be the best choice that you should take forward. So this is what quantum chemists and theoretical chemists do. A very brief, basic idea, but yeah, this is what it is.
Okay, anyone else would like to ask any question? This is the time you can ask what you want from ma'am.
You
So,
can ask, you have my mail ID. You can reach me whenever you want if you have any doubt. Okay.
ma'am, I can see one question now in the chat box.
Yes.
Question from Surabhi Pilani.
Hmm.
She's asking about ma'am career option in polymer.
Okay. Polymer people, basically, polymers itself is a very interesting field, to be honest. Nowadays, one of the energy technologies is that involves solid oxide fuel cells that depends on polymers or a lot of it. There's some polymer fuel cells, etc. Okay, that apart, people who work in polymer, they can find careers in paint industry, textile industry, agriculture. Everywhere you have long chain molecules involved, polymer specialists would be required there. I think this probably polymers is I think one of the most upcoming chemical industry according to me. Okay. Or see, the
Anybody
thing
else?
is, I can also help you. Like, suppose I work in material chemistry, so there are some fields which I might not be aware of so much, but you can write to me if you want. I'll have colleagues who are working in those areas, like polymers. I have a very close colleague who works completely in polymers. I can give you his contact, and you can, write to them directly, and they would be very happy to respond to you.
Sure, ma'am. We will share your email ID with the students if they can get in touch with you and ask you in person. Yes, ma'am. Yeah. So I guess we are done with the question and answer session now, and we will move forward. with the vote of thanks to be proposed by Savita ma'am.
Good afternoon, all. Thank you so much, ma'am, for such a wonderful talk. First of all, we would like to present virtual memento to our guest, Dr. Vinita Gupta. We all have had a wonderful day listening to the informative talk by Honorable guest speaker, Dr. Vinita Gupta. It was definitely an enriching experience for each one of us. I can assure you that we all have learned many new things from you. So thanks a lot, ma'am, for sparing your valuable time for giving this session. I also take this opportunity to thank all the honorable management members for their continuous support. I would like to thank our respected principal, Dr. Leena Sarkar, for her valuable guidance and support during the organization of this event. And I would also like to thank technical team. I thank all the participants and hope they must have been elated hereafter to some degree. I wish them all the best for their future endeavors in their life. Thank you so much, everyone. I request, yes, ma'am.
May I take a minute? I thank you all for this virtual memento, and let me place on record my thanks for Professor Dr. Leena Sarkar. It was indeed a pleasure interacting with her last few days, and thank you to her team also. I see a very young and dynamic team. Thank you so much, and a lot of thanks to your management also for giving us this opportunity to interact with the younger kids. Thank you so much.
Thank you so much, ma'am. I request all the participants to kindly turn on their videos so that we can take photograph. Please turn on your video, everyone, all the participants.
Thank you so much, Vinita ma'am, for accepting our invitation and for such an enriching session.
The pleasure is all mine.
Yeah, thank you, everyone.
Okay, Dr. Sarkar, I should leave now. Is that okay for me to leave?
Yeah, thank you so much, ma'am. Thank you once again.
Thank you. Thanks.
You made our day. Thank you, ma'am.
Pleasure interacting.
We are looking
Thanks a
forward
lot.
to many such sessions in future, ma'am.
Same here, same here. Let's look forward to many works, many workshops together. We'll be in touch with you. Yeah? Okay.
Thank you, ma'am.
Thank you so much.
Students, please don't leave the group. We will share feedback link in group.